All right. Good morning, everyone. My name is Kyle Escamilla, and I am the training coordinator for EandM. Thank you all for attending our webinar today focused on what's new with SICK photoelectric sensors. After the webinar this morning, we will be doing a short Q&A, so please type any questions or comments you guys have into the Q&A box, and we'll get to them at the end. Now I'd like to introduce your speaker for today. We have Akshay Bhatti. Akshay is a product specialist here at EandM. Good morning, Akshay.
Good morning. Thank you, Kyle. Good morning, everyone. Like Kyle mentioned, my name is Akshay Bhatti, and I'm the product specialist over here at EandM for SICK sensors and our robotics lines. So today I'll be starting with this webinar on photoelectric sensors from SICK. So new SICK photoelectric sensors. Let's start. So the agenda for today would be basics of photo-eye or photoelectric sensors, then distance sensor, which is DT80, then color contrast sensor, KTS, KTX series, presence detection sensor, which is W10, and then we'll get into the demo. So just introduction, what exactly is photoelectric sensor? So anything which has optical light emitted by a sender will come into photoelectric sensors, because definitely that sensor will have some kind of receiver, either in the sensor itself or in some other housing or somewhere in the photoelectric sensor housing. So what exactly does the photoelectric sensor do? So basically detects the change of light intensity. So it emits a light pulse from the center, and the receiver gets that light. Either it doesn't get that light and it triggers an output, or it senses a little bit of change in the light. So now, what are these sensors used for? Typical applications would be presence of an object. Either we have to make sure whether the object is there or not, or it can be used for measuring distance or something else like a target, like what color contrast sensor will do, which is a black mark or any color. So anything where we have to see the presence or measure distance. Now, what are the components in a photoelectric sensor? The first or most important is, of course, the light source or the emitter that emits the light pulse, receiver, and signal converter and amplifier. So signal converter is basically to change the light output to, analog or digital. Now, let's get into the steps or some factors which help us determine what exact photo eye will be needed for an application. So the first most important thing is get to know the application, get the requirements. Now, when we talk about requirements, there are a few things. For instance, what type of target we are looking at? Is it a black object? Is it shiny bottle or shiny cap or transparent material bottle or something which is highly glossy? So things like that. Based on that, we'll decide which sensor family and sensor principle we have to go with. The next important thing is sensing distance. Now, sensing distance is another important factor, because that helps us determine whether we have to go with something without a reflector, or we need a through beam sensor, or something really high distance with the help of a reflector. So that's the second point. Third is mounting constraints. So we have to see like how we can mount the sensor, what is the orientation, what's the space constraints. Like, for example, in robotics application where I run into, they're always their high priority is the space. So we go with, micro form factor sensors. So that's another thing to look for. And last is environment. Is it outdoor, washed down? In that case, we have to go with IP69K. We don't have an option. Now, next thing is sensing mode. Based on our application requirements, we'll decide which sensing mode we should go with. So the first one is background or foreground. This sensing mode is typically used when we have something which is not for long distances. So usually around up to 500 millimeters, then we go with background suppression or foreground. Now the decision between background and foreground depends on the background itself, whether the background is variable or it's fixed or how far is it from the target, based on those factors. Second is retroreflective. So this sensing mode is good for, transparent materials or clear materials because we need reflector on the other end to bounce off maximum light. So, and also for sensing ranges higher than 500 millimeters, we go with retroreflective. Last one is through beam. In this case, the sender will be in one sensor and receiver will be on the other side in a different sensor. This sensing mode is good for applications where distances are really long. So in those cases, through beam is the right fit. But of course, every sensing mode or every sensor has some disadvantage, sorry. And for this one, it's the alignment itself. So when we talk about large distances, it's difficult to align the sensor right on so that receiver receives the sender's light. Now, the third thing is output type. So we have to figure out what the PLC accepts, whether it's PNP, NPN. We have PNP, NPN, and something called push-pull, where it accepts both. So depending on what's needed, we select that particular sensor. The second thing is light operate or dark operate. Now that's something which basically reads the status of the receiver LED in the sensor. So let's say we have background suppression. So light operate would light on or turn on the sensor with like output LED when the receiver receives the light. And that happens when there's an object. But when we talk about retroreflective or through beam, it's completely opposite because when the object is there, the through beam receiver won't receive a light. So it's more about, again, the PLC, what outputs they would accept. And these three are the most important, but of course there are other things like what is the connector type preferred, flying leads or male connector, and what about mounting in terms of whether we need nose mount or side mount and things like that. There are many more factors. If we consider that, we can narrow down the exact sensor family, but these three areas are the most important. Now let's get into the sensors for today. Our new release from SICK in distance sensor family, or to be precise, mid-range distance sensor family is DT80. This sensor is very impressive, especially because of the long distance and the precise measurement at that distance. Usually sensors in the market, they would say, oh, they can go up to 80 meters, 100 meters, but they won't talk about accuracy, or they would say up to 10 millimeters or things like that. They won't be very precise in their spec sheets. But for this sensor, at 80 meters also we'll get the accuracy of plus minus 2 millimeters, which is very impressive at that long distance without a reflector. So that's the most important spec of this sensor. Now, other things are you can have like if you need IO-Link, then it is IO-Link compatible. It is IP67 housing, metal housing, and can go in increments of 0.1 millimeters. That's the resolution. And it has a very nice display. So you don't have to rely on PLC for the analog output, especially in robotics application where they need to read the output right on from the display. So this sensor gives you that feature. You can have distance output from the sensor itself. The next one is KTX. It's a color contrast sensor. It's not a new release, but it was released recently, like I think in last year. So, but I wanted to highlight this sensor because this sensor is very powerful in a way that it can do contrast and color both for a very good price point. So this sensor has something called twin eye technology. In that, what it does is that it enables the sensor to detect even glossy materials or very like complex contrast where the contrast difference is very minimal, or something where there's a lot of vibration or fluttering materials. So in those cases, the sensor works very well. Sensing range, it goes up to 200 millimeters. Switching frequency 70 kilohertz. Now that's something which is again very impressive because other sensors in the market, especially photo eyes, they would go up to 1 kilohertz when it comes to high speed application. So 70 kilohertz in itself is very fast. So you don't have to worry about very fast moving targets or color marks or uh, like eye marks for label cutting and stuff. Last sensor is SIG W10. This is our new release, which was released last month. And again, it's a very powerful sensor. It's not a regular photo eye. I would say it's a high performance photo eye, which makes it a perfect fit where regular photo eyes fail in tough applications. So this sensor provides a lot of benefits. Firstly, it's again IP69K and then stainless steel housing. And it has a touchscreen display, which is very unique. Other photo eyes in the market, you have to have you have to use potentiometer or buttons to set your switching points. But in this case, it makes it really easy to configure through the touchscreen display. And then the range, we have two variants. It goes up to 400 millimeters and 700. And then we have two digital outputs, but with IO-Link, we get four. And then this sensor can be used for different applications in a way that, let's say, if you have to detect bottles at very high speed. So we need a counter. In that case, we go with the speed mode. If you need to detect a precise measurement, like in terms of millimeters, then we'll go with precision mode. So it has different modes. Basically, in short, this sensor can solve different applications. And lastly, we also have this lock feature where you lock the screen so that other operators or other people cannot change the configuration. Okay, now let's get into the demos. So change the screen. Okay, let's start with DT80. Can you guys see my screen sensor?
Yeah, it's popping up okay.
Okay, good, thank you. So this sensor is DT80, so you can see. So it has cool display where you get the sensing distance right on the display itself. It has few modes which you can configure through the sensor itself. For example, first thing is you can check the signal level. If I am on black, the signal level goes down because all of the light is absorbed. If I look at white, the signal level goes up. So it's good in troubleshooting where sensor is not working well. Then you can get the signal level intensity from the sensor itself. Next thing is quick setup. So I'm in a mode which is called quick setup. If it's not clear, then basically the first option is accuracy, speed, and distance. So based on what we need in the application, we can select a mode and then cycle time and response time changes. For example, the response time will be a little bit longer when we are in distance mode because we have to see long distance up to 80 meters. So things like that. Then the next one, after we select the mode, we can do the manual setup. This is where we select the cycle time manually, like what cycle time we need and filters. Let's say if we have variable readings, then we can have something called average filter to get the average readout from the target and things like that. The next one is interface. So this is again important thing. The first one over here, it says output Q1, output Q2, and input. So you can select input where you can define input, have like teach in process from the input itself, or you can select your Q1 through the display itself by keying in the value that what distance you need. So now let me go into the IO link where I want to show what more features or things you can get out of the sensor, and also you'll be able to see the sensing reading very clearly in the IO-Link, because I think in the menu it's not really clear. It's getting a little blurry. So I'll share my screen. So this is our software called SOPA's engineering tool. It can be downloaded from our website, sig.com, for free. So once I connect to the software, I'm connected via our SI-Link master, which is a SIG device used to communicate through sensors via IO-Link through our software. So I'm connected with DT80, I'm live. I double click on the sensor, new window pops up, which is the DT80 itself. So now, really quick, one thing to notice here is the signal strength. So right now you see 2600, but let's say if I put a black object, then the signal strength goes down. On white, it goes 2500. Again, this is a cool feature when we are doing troubleshooting or checking the targets, how good, reliable they are in terms of measuring distance. So that's one thing. This is overview, the live overview as in Q1, QA, which is the analog output, and input, which we haven't selected for now. So let's get into the distance measurement. Over here, we can select single point switching, so we can define our distance. This is our current measure value. Right now, sensor is seeing 1740 millimeters. We can either have window mode, where we can have two set points. We can drag or key in the set points over here. But like, for example, 229 to 9625, that will be our window. So whenever the target is between this window, it will trigger an output. So that's about our switching point, and this one over here is for analog. So we can set our 4 milliamps and 20 milliamps distance. We can have analog as our Q2 as well. So that's another switching point. Now let's get into the actual live measurement. So I am pointing my sensor towards a wall, and the distance is 5430, approximately 5430 millimeters, which is 5.4 meters long distance. So I'll set my 4 milliamps as 5300, or let's say 5400, and then this one as 5450. So my values are set 5430, 5440. Now what I want to do is I have this pamphlet here from, as you can see, Motorman Robots. It's very, like, thickness is very small, around 1 millimeter. So I'll go at that distance, which is 5430 millimeters, and you just look at this reading over here. So it will change by 1 millimeter, and you'll also see a little bit change over here in the output itself. So I'm going towards the target. So at this distance, I put in my pamphlet, and the reading will change. If I remove it, it will go down back to the original value. If I put it again, the reading will change. So that change of 1 millimeter, that change of 1 millimeter at a distance of 5.4 meters, that's very impressive. So that's what I wanted to show, that even at large distances, these small increments can be detected by the sensor. So that shows that this sensor is very reliable. And again, I'm using this sensor at that distance without a reflector. Usually other sensor in the market, or even the predecessor of this sensor, would work at that accuracy or that precise measurement with a reflector. In this case, I'm not using any reflector or anything like that. So that was all about DT80. We have more things, like for example, diagnostic, where If there's some error or sensor is not function, we get the error codes, which helps us determine what exactly the problem is. We have input conditions, so you can set input for, switching off the sensor or having some preset distance value. Preset distance value is basically when we don't get the expected measurement, we can have some kind of offset to that actual value because let's say the target is not stable or things like that. So for now, I have kept it in off mode. And yeah, that's all about DT80. So now let's move to our next sensor. Next one we have here is KTS-KTX sensor, which is color contrast. So this is the sensor here, as you can see in the camera. We have two modes in this, color mode or contrast mode. Now, what I want to show you is I'm having this sensor, this target here. It has different shades of color. This sensor is so precise that it detects the difference between this one and this one. Let's say, for instance, in my experiment here, I'll teach in on this target. It will only trigger on this target and not this or this one. So it's that precise of a sensor. And then the teaching process is really easy. So as you can see, I'm focusing on, my target is this second shade of green, and this is my light spot. So if I put it here on the light spot, I'll press set. Now it says TCH, which is teach. I press set again. It says 1P, which is 1 point. So I'm in 1 point mode, which is a color mode. I press set again, and it says first point, set again. It learns the target, and 100% teach and done. This orange LED is my output LED. So as I move to a different shade of green, the output turns off. So if I go back, it turns on. If I go ahead to the next shade, it turns off. So as you can see here, I'm on green shade. If I go here, it turns off. If I go back to my green shade, it's on, off, on. So what I'm trying to show here is that the precise measurement at every color. Now let's take another example, which is again way more complex than what I just showed you. I have this here. This looks almost same colors, and let's teach in on middle one. So set, teach, 1P, first. It learns. So I'm on this. If I go to a different shade, it doesn't trigger. If I go back, it triggers. Doesn't trigger. So that's about this sensor. Now, really quick, I would like to show you on the software itself, like what additional features we get out of the software. So I'm connected to the sensor. Do you guys see the software? Kyle, can you see the software?
I don't see that you're sharing your screen currently.
Oh.
There we go. I see it now.
Yeah. So right now I'm in color mode. One thing I would like to highlight is mounting feedback. So this is very good when you have vibrations in the target or the mounting itself. So if we start, and if you see the target, if I am not aligned properly, let's say I'm at an angle, the output percentage goes down. So it's good to align the sensor to the target. If it's 90 degrees to the target, it will be perfectly aligned. So that's a good feature of giving mounting feedback. Another thing through IO-Link is that we get the actual RGB values. So you know the threshold that, okay, this color is at this is the uh, this is the RGB value for it. So uh, things like that. Another thing I would like to show you here is the settings. So which is sensitivity. So usually by default, our sensors will be set at middle, which is a wider threshold. But like I was doing an experiment for those precise colors, so I had my sensitivity set to fine. So the threshold lowers down. Now that's something which is again, you can change it based on your target and how precise measurements you want. And another thing I would like to highlight here is the jobs. So basically, right now I have taught in that color. If I want to save it, I just save the job one, okay. So I can save up to 5 different jobs and then change the job or recipes based on my target. So that's another cool feature. It's just like if you're familiar with vision cameras, so you would change recipe based on what's needed. It's the same way. So another thing is the teaching part, which is really quick, which is like I just showed you, it's similar to that, but in this case, you would see on the graph itself. So as soon as something is taught, the RGB values gets decided, and then that's how sensor learns it. If I go back to a different target, the RGB values change. So it's out of threshold and it triggers the out. So that's all about color contrast sensor. Now let's move to our last one, which is W10. I see I'm running out of time, so I'll get into W10 demo. But in any case, that was it about KTS KTX. So the last one over here is our W10 sensor, which is our brand new release from SID. The sensor looks like this. Okay, this is my light spot. Got it. All right, so in this sensor, really quick, the first thing is that you can lock the sensor. As you can see, right now I'm seeing the live value. That's the distance value, 76 millimeters. The small value here, which is 73, that's basically my teaching point. So if I want to lock the sensor, I just go in lock. I just lock the sensor. Now, whatever I do with nothing would change. So I'll have to unlock it to change the configuration. So that's one cool thing about the sensor. Another thing is the way how you can change things from the software, from the display itself. Let me get into the output first, which is this mode here. So over here, I have Q1, Q2. If I go into Q1, I can select light operating and dark operating. Let's say I select light operating. Then I have option of PNP, NP, and push-pull. So I select PNP and I'm done. So this is very cool feature because usually you have to change or switch the wiring to get a different output. In this one, you just select it from the display itself. So that's good thing or uh, one benefit of the sensor. Next thing is let's get into the demo here. So my target or background, I'll take this as my background, which is very reflective as you can see. So this is my background. And what I'll do is I'll take this as my target. Now the thickness of this target is very less. So there's not much difference between background and target. So this is one of the toughest applications. And moreover, the target color and background is the same color. So it's very hard to detect such type of target on this background. So let me do the teaching. I'll show you how quickly the teaching can be done. So if I scroll up, I select on teach, I select 2-point teaching. It says put the target and do the teaching. I put the target here, I teach it. It learns the target. Now it's asking for background. I'll remove the target, teach it on background, and done. Now it knows that what to expect. So when this target comes in, you can see this output LED here, it will light up. So it's that precise that it can detect at such a reflective or shiny material and with this target. Now let's take something which is black, which absorbs all the light, same thickness, and again, it detects. Another target is something like this. When we talk about such objects, it's not flat or uniform. It's again reflective, glossy, and the output is always on throughout wherever you go. So that's one thing about the sensor. One last thing, when we talk about transparent materials, SICK doesn't market the sensor as transparent, but what I want to highlight is that I did an experiment using transparent material and it detects very well. So transparent material without a reflector to make the sensor work 100% reliable, it's very, very hard and close to impossible. Reflector is definitely needed when we talk about transparent materials, but in this case, as you can see, without reflector, the sensor triggers an out. So that was all about the demo for today. And with IO-Link, I just wanted to highlight you get additional switch points. So in that way, you can have more switch points instead of just 2 switch points through the sensor. Okay, so that's it for today.
Awesome. Awesome. Great presentation, Akshay.
Thank you. Thank you.
I know we have gone a little over time here, but I just want to give the opportunity in case anyone has any questions they want to ask here before we close things out. I know there was kind of a lot of material squeezed in, but just want to see if any of you guys have any questions that you might want answered while we got Akshay here with us. And that can be done using the little Q&A box. Okay, we got one in here. Someone asked, what is the maximum sensing range for the KTS/KTX color contrast sensor?
You can go up to 150 millimeters, but if you need something longer than that, then we have introduced a new color sensor family, which can go up to 500 millimeters. So we do have other sensors if you need something more than that.
Awesome, awesome. Just another minute here in case anyone has anything else. Oh, someone asked the same question, but for the W10 sensor. Like, what's the maximum range?
700 millimeters. We have two variants. One goes up to 400 and one goes up to 700. Any other questions?
Oh, here, Glenn, did you want to talk here? Let me see if you wanted to ask your question out loud. I saw you have your hand raised.
No, I'm good. Thank you.
Oh, okay, no worries. Awesome. Just want to make sure you're taken care of. All right, perfect. I think we can close things out there. Thank you, Akshay, and thank you to everyone who attended. If anyone would like to review any portion of this webinar, a recording will be available on our YouTube channel and on our website, EandM.com, once it's available. And we will also be sending a copy to everyone here who attended via email. So I'd like to thank you all again for attending, and I wish you all a great day.
Thank you, everyone. Have a good day.